Now that we are sure that Podman is configured correctly and that we have downloaded the AFL image, the next step is to get our target from the AlexFacZin module repository, instrument it, and compile it using the AFL++ compiler. So, we clone the repo with the git clone command, and we start exploring the content. As you can see, the repo contains 3 exercises in 3 different folders, and our focus for now on the first one. So, we cd inside. The first exercise contains 2 files. The first one is the CMake file that defines a CMake project called SimpleCrash and specifies that an executable name, SimpleCrash, should be built from the source file simplecrash.c++. The second one is the source code of our program that we want to fuzz. As you can see, is a C++ code with a main function that do some stuff. Okay. Now we can run the AFL container and mount the folder of the first exercise in the target directory under the root of the container. To do that, we use the podman run command, passing rm to remove the container after it exits, -i to keep the standard input open, even if it's not attached, -t to allocate a pseudo-tty for the container, and -v to bind a volume into the container. So basically we are mounting the exercise1 folder inside the container. If you want to know more about the parameters passed to Podman, you can always use the help utility. So for example, you can run podman help. Or if you want something more specific for a sub command of Podman, you can run, for example, podman run. In that way, you can have a clear overview of all the parameters that are used in this command. Okay, so now we are inside the container and we can instrument our target. First, we have to go inside the target directory that is mounted under root, that contains the exact files that you found in the exercise1 folder. Now, we can create the build directory and we go inside. Next, we need to add the AFL++ tooling to the compiler. This will instrument target by using the AFL CLang fast compiler provided by AFL. And we can do this with this command. So, first we set the cc and the cxx variables to AFL CLang fast and AFL CLang fast++. In that way, we are telling the system to use the AFL compilers for both C and C++ code. It's important to use always the same compiler for both C and C++. Now we can create a CMake file. And if you are curious about how these changes are reflected in the compilation settings, you can search for AFL-related entries in the makefile by running, for example, grep recursive, and we look for the AFL string. In that way, you can have an overview of all the changes that AFL include in the compilation process. Okay, now that we have set up our instrumentation, we can compile our target with the make command. And as you can see, now we have our output in the SimpleCrash binary file. To run it, we can simply do like this, and we see the output of the program. So this will run the target program, and we can start using it. Now we can play a bit with the program, for example, passing a random string, and we see that the output, it's the first character of our string.